welcome to Algeomulus Prep Academy. Today's video will be about related rates with ladder problems.
A 14-foot ladder is leaning against a wall when its base starts to slide away from the wall. By the time its base is 10 feet from the wall, the base of the ladder is moving away from the wall at a rate of 6 feet per second. At what rate is the top of the ladder sliding down? Let's diagram what's happening. Let x be the distance from the wall to the bottom of the ladder. We are given that dx over dt equals 6 feet per second when x equals 10. The ladder is 14 feet and will not change because it is a constant. Since the ladder is moving down the wall, dy over dt is going to be a negative rate. Next, we will use the Pythagorean theorem and find its derivative because we have the rates of change. The Pythagorean theorem of the situation is x squared plus y squared equals 14 squared. We plug in 14 because 14 feet is the hypotenuse and the height of the ladder. It will be a constant. First, we need to know the value of y. Since we already know x, plug it into the equation and solve for y. Since the height of the wall has to be greater than 0 feet, the y value will be positive. Since it's a triangle, we will use the Pythagorean theorem and derive it to find the value for dy over dt. Now, isolate dy over dt. Solve for dy over dt by plugging in dx over dt, x, and the y values. Now, solve for dy dt. Remember to round to 3 significant figures, and the value for dy over dt equals negative 6.124 feet per second.
A ladder is 40 feet tall and falls down a vertical wall. What is the horizontal distance between the wall and the point where the ladder touches the ground when the ladder's base is moving along the ground 1/4 as fast as the top of the ladder moves down the wall? First, we draw a picture to visualize what is happening. Then, we write down the important information. We know that the ladder is moving down the wall y. We are also told that the rate of change on the ground is x. Since it says moving away, draw an arrow designating that it moves away. From this model, we know that the rate of change for the ground, or dx dt, is equal to negative 1/4 dy dt, because y is decreasing in value. Then we have to figure out what we are finding. We are trying to find x in this problem. Since it is a distance with a value greater than 0, x is equal to a positive number. Using what we know about triangles, the Pythagorean theorem can be applied to this problem. Plug 40 feet in for c because it is the given length of the ladder and it is the hypotenuse. Derive both sides of the equation and then isolate one of the rates on a side. This leaves us with dx dt is equal to negative y over x dy dt. Go back to the equation dx dt is equal to negative 1/4 dy dt. Substitute dx dt with negative y over x dy dt. Then solve for y. Now go back to the Pythagorean theorem from earlier and use y is equal to 1/4 x to plug in for the values of y. Then solve for x. Since we are finding a distance, x must be a positive number. Solve for x and show 3 significant figures past the decimal. The answer is x is equal to 38.806 feet. Don't forget the units.
ladder 15 feet long is leaning against the wall of a house. The base of the ladder is being pulled away from the wall at 3.5 feet per second. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 5 feet from the wall. This situation can be represented by a right triangle where A represents the base, B represents the leg, theta represents the angle in question, and the hypotenuse is 15 feet long. By using the equation sine theta over opposite over hypotenuse, we could solve for d theta over dt. Using the Pythagorean theorem, we can solve for side B. To solve for secant theta, we first need to calculate cosine theta, which equals adjacent over hypotenuse. By flipping this value, we get secant theta. Substitute the values for secant theta and dA over dt into the original equation, and then solve for d theta over dt. After solving, we found that d theta over dt equals 0.247 radians per second.
Thanks for watching this video, and please make sure to like and subscribe to Algae Omnibus Prep Academy for more math help.